So ladies and gentlemen, you are welcome. So in this video, we are going to look at how to calculate the empirical formula during the combustion or after the combustion reaction. So a compound or a hydrocarbon compound is combusted in oxygen and the product are 27.4 gram of carbon dioxide and 22.4 gram of water. Then what is the empirical formula of the compound? So clearly we can see that for the carbon dioxide, it has 27.4 gram. 27.42 gram. So therefore, the most important thing here is to calculate the molar mass of carbon dioxide. So of course, carbon dioxide, it has one carbon and of course two oxygen. So one carbon times the molar mass of carbon is 12. Then plus oxygen, we have two oxygen here times 16, which is the molar mass of oxygen. So of course 1 times 12, it will give us 12. So we have 12. Then 2 times 16, we have 32. So after we add everything, it's going to give us 44 gram per mole for carbon dioxide. And then of course for water, we have also water. So in water, we have 2 oxygen. So we have 2 hydrogen. So we have 2 times 1 plus 1 oxygen, which is 1 times 16. So 2 times 1 is 2, then 1 times 16 is 16. So we have 18 gram per mole for water. So the next thing is to calculate the number of moles of carbon dioxide and that of the oxygen. So and that of the water. So we know that of course mole is equal to mass all over molar mass. So let's start with the mole of carbon dioxide. The mole of carbon dioxide, and of course we have the mass, which is 27.42 divided by the molar mass. So the molar mass is 44. So therefore 22.42 divided by 44. So we have this. So therefore 27.42 divided by 44. What are we going to get from here? So I think we are going to get, after we use our calculator, we are going to have 27.42 divided by 44. So we are going to have 0.6232 mole. So that is the mole of carbon dioxide. So it means that we have the mole of carbon dioxide here. The mole of carbon dioxide, let's give it here, is equal to 0.6232 mole. 0.663232 mole. So we have that. Then the next thing is the number of moles of water. So of course, for the number of moles of water, we are going to say, okay, that's still okay, 18. So we have 22.46 divided by 18. So 22.46 divided by 18 is going to give us 1.248 mole of water. We now get the number of moles of water. So the next thing now is we know now the number of moles of water, the number of moles of carbon dioxide. So then the next thing is, how are we going to calculate the number of moles of carbon from carbon dioxide? It is simple too. So how are we going to do that? So we know that of course, from our calculation, 1 mole of CO2 give us 0.6232 mole. And of course, for 1 mole of carbon, what are we going to get? So we cross multiply. So of course, even from here, since the number of moles are the same, here is 1 mole, here is 1 mole. So after just crossing multiply, this time this is going to x times 1 mole is going to give us 1, and then 1 mole of carbon times this is going to give us the same thing. So therefore, the number of moles of carbon is going to be 0.6232 mole. So we now get the number of moles of carbon. Now what of the hydrogen? How are we going to get the number of moles of hydrogen? So in this case, the number of moles of water, 1 moles of water, of course, give us 1.1. It gives us 1.248 mole. Then what of if we have 2 moles of hydrogen? Because in water we have oxygen will usually come as a diatomic molecule. So oxygen usually come as a diatomic molecule. So therefore, if it reacts with hydrogen, it must react with 2 moles of hydrogen. So therefore, for you to have a complete formation of water molecules in a balanced equation, we have to have 2 moles of hydrogen. So we have it in X. So we cross multiply, and at the end, we are going to have X. So therefore, our X in the case of water, is going to be 1.248 times 2. So 1.248 times 2 is going to give us 2.496. Going to give us 2.4956. 2.4561. So we now have the number of moles of hydrogen and then the number of moles of carbon. So now what are we going to do next is to calculate the number of, or the ratio between the two. So now by looking at the number of moles of carbon, of course, this is for the carbon and this is for the hydrogen. So between them, which one is the smallest? The smallest one is that of the carbon. So we are going to divide the equation through by the smallest one. So therefore, now what we are going to do, we are now going to say for the carbon, we have 0.6232. So we divide it by also 0.6232. And then for the hydrogen, we have 2.4956. So we also divide it by 0.6232. So this divided by this is going to give us 1, and that of the hydrogen, we divide it by also 0.6232, which of course is going to give us 4. So you see that the ratio of carbon is 1 and the ratio of hydrogen is 4. So we have CH4 as the empirical formula of the hydrocarbon. So ladies and gentlemen, if this is the first time you are coming to my YouTube channel, please subscribe. Thank you.